In the previous video, we looked at writing nuclear equations specifically for 4 different types of radioactive decay. In this video, we're going to look at balancing general nuclear reactions, or nuclear equations. And so, similar to the last video, in order for a nuclear equation to be balanced, the mass numbers on the left-hand side, or the reactant side, have to be equal to the mass numbers on the product side. And so we can see that this particular equation is balanced. Right? 4 plus 27 is equal to 31 on the left, and 30 plus 1 is equal to 31 on the right. And also for nuclear equations to be balanced, the atomic numbers have to be equal on both sides. And so we can see this equation is balanced in that respect too, because I have 13 plus 2, I have 15 on the reactant side, and I have 15 on the product side. This is the same reminder I had in the last video. In order to be successful in completing and balancing nuclear equations, there are a number of subatomic particles that you need to have the nuclear symbol memorized. And these are the ones that you need to know for our class. So this is the way these questions are frequently asked. We're given a partial nuclear equation, and then we have to fill in the missing piece. And the way we determine what the missing piece is using the mass numbers and atomic numbers. The atomic number and mass number of the missing piece have to be whatever they need to be so that the atomic numbers on the products are equal to the atomic numbers on the reactants. And the same is true for the mass numbers. So I always start with the atomic numbers. So we can write a simple mathematical formula using the information that we're given to find out what this missing atomic number is. And so on the reactant side, we have 53. Then whenever we have the arrow, I put an equal sign, and then I have 54 plus x, where x is the atomic number of this missing piece. And so to solve this equation, I'll just subtract 54 from both sides, and so then I end up with a negative 1 is equal to x. So the atomic number for this missing piece is negative 1. And then I can do the same thing for the mass numbers, but we can see these are going to be easy, right? Because it's 122 for the iodine, it's 122 for the xenon, so the only way the reactants can be equal to the products is if this is a 0. All right, and so this is where knowing your subatomic particles becomes really important. We need to know what has an atomic number of -1 and a mass number of 0, and that, of course, is the electron. And so now we have the complete and balanced nuclear equation. Okay, here's another example. We'll do it exactly the same way. We'll figure out what the missing piece is based on the atomic numbers and the mass numbers that we already know. So on the reactant side, if we do the atomic number first, I've got 7 plus 1, and then that has to be equal to x plus 2. So I have 8. So then x has to be 6. I'll do the same thing for the mass numbers. Okay, so this is not a subatomic particle. It's got an atomic number of 6, so this corresponds to an isotope of some element. So I'll go to the periodic table to figure out what this element is. So we look at the periodic table, we find atomic number 6, so this is a carbon atom. So to finish our problem, we put in the carbon. All right, I've got one more example. All right, this works the same way as the last two that we did. The only additional wrinkle that we have here is now I've got a number in front of one of the entities in my equation. And so just like a chemical reaction, when I put a coefficient in front of something, I'm just saying I have 4 of these neutrons. So when I'm doing my math, I've got to multiply 4 times 0 for the atomic number and 4 times 1 for the mass number. But other than that, it works exactly the same way. So when I do the atomic numbers on the reactant side, I've got x, and then I have plus 4 times 0. All right, well, of course, 4 times 0 is just 0. So atomic number is 100. I'll do the same thing for the mass numbers. And now I have 4 times 1. Okay, but this just ends up being... Then I'll subtract 4 from both sides. So x is 252. All right, so then I go back to my periodic table again. And I find element 100. It's fermium down there on the bottom right. Finish our problem. All right, so with a little bit of practice, I think you'll find balancing these nuclear equations is not too bad.